Welcome to Ms. Park's Flipped Classroom. In this lesson, we're going to review square roots and radicals. Remember, this little symbol right here means the radical symbol. And in general, the square root of x squared is equal to the absolute value of x. The product property for square roots is that if you have the square root of a times b, that's equal to the square root of a times the square root of b. So you can leave these together, or you can break this apart. A has to be greater than or equal to 0, and B has to be greater than or equal to 0, because remember, for it to be a real number answer, it has to be positive. Okay, the division property for square roots says that if you have the A divided by B, the entire thing, you can break that apart into the square root of A divided by the square root of B. And in this example, A has to be greater than or equal to 0 because it has to be positive. B has to be greater than 0. It cannot be equal to 0 because if it were equal to 0, we would be dividing by 0, which we're not allowed to do. So if you had a problem, you could either divide and then take the square root, or you could take the square root of them separately and then divide, whichever is easier. For our example, we're going to simplify the square root of 50. And there's two different methods that I'm going to show you. One is to rewrite 50 as the product of a number and a perfect square. Well, we know that the square root of 50 is equal to 25 times 2. So we break that apart. The square root of 25 times the square root of 2. The square root of 25 is 5. So the square root of 50 will simplify to 5 times the square root of 2. The second way is to do the prime factorization of 50 and then look for groups of 2. So we do 50, we know 2 times 25, circle the 2 because it's a prime number. 25 is 5 times 5, circle both of those because they're prime numbers. So we know that 50 is equal to 5 times 2. We have a group of 2 5s, so we can take out 1 5 and get rid of that group. And our answer will be 5 times the square root of 2. The same answer we've got up here, just a little bit different way to solve it. In this problem, they want us to simplify 5 divided by 11. Well, if I break this apart, the square root of 5 and the square root of 11, neither one of those are perfect squares. If I divide, that doesn't help me either. So there's really nothing to simplify in this problem. However, when I break it apart into the square root of 5 divided by the square root of 11, mathematicians do not like radical signs in the denominator. So they always want you to rationalize the denominator, which means we're going to multiply this by a form of 1. Because the square root of 11 divided by the square root of 11 is just 1. So it doesn't change our answer, just the way it looks. So the square root of 11 times the square root of 11 would give us 11. And the square root of 5 times the square root of 11 would give us the square root of 55. So now we have an answer that is rationalized. There is no radical sign in the denominator.